Okay, we shall get started then. And today, we are going to deal with hypothesis tests. Okay. Last week we dealt with confidence intervals. We said we've taken a sample, and based on the sample we came up with a range or an interval of plausible values for the population parameter. Okay? So maybe we took a sample of 200 people and 80 of them said, that they have this trait or whatever, okay? So according to our sample, 40% of our sample fits some category. Based on the sample, what can we say about the population? We would say, well, I'm 90% confident that the proportion in the population is between, let's say, 36% and 44% if our margin of error was 4% or something like that, okay? So that was confidence intervals. With hypothesis tests, we're doing something similar, but from a different perspective, okay? We are going to take a sample of data, and we're going to use this data to either support a claim, or maybe it won't support the claim, okay? It's going to be used as evidence. And at the end of the day, we'll say, this data provides evidence to support this idea, or this data is not enough evidence to support the idea, okay? So, it's kind of like a trial, okay? Someone is on trial. Just imagine a criminal case, and the defendant is on trial, and the defendant is trying to avoid going to jail, right? And so the prosecution presents evidence and says, and presents evidence to the jury or the judge and judge. And the jury has to decide, does this evidence convince me that the defendant is guilty, or is it not enough evidence to convince me that the defendant is guilty? And that's how a trial works, right? So, if a jury says there wasn't enough evidence to bring about a conviction, it doesn't necessarily mean that the defendant is innocent. It just means there wasn't enough evidence to bring a conviction, okay? And that's an important distinction to make, because that's how hypothesis tests work, okay? Our data serves as our evidence, and we ask, does our evidence provide enough evidence to come to this conclusion, okay? In a trial, the conclusion is that the defendant is guilty, okay? In a hypothesis test, it's that we reject the null. Okay, we'll talk about that in a moment. But it's presented that way. Now, so the conclusions that you can make as a jury is either the defendant is guilty, or the evidence doesn't prove that the defendant is guilty, so we conclude that the defendant is not guilty. Okay? So your choices are guilty or not guilty, and it's never, the jury never says, we find the defendant innocent, okay? The defendant might actually be innocent, but they would never say, the jury find the defendant innocent. They always say, we either find the defendant guilty or not guilty, okay? Yes, we have a question.
Is that why convictions always stay with you?
Is that why convictions are always, I'm sorry?
You know how, if you're convicted of something, it stays with you? You never actually prove it? Is that why that's sticking up?
Yeah, I don't know the inner workings of our justice system, but but the premise is, we always, the defendant is always presumed innocent until proven guilty, and either the evidence provides, the prosecution has to either provide enough evidence to convince the jury that the defendant is guilty, or it's not enough evidence to convince that the jury is guilty. Okay. So we're doing that, okay? So just think of kind of that perspective or that process, okay? Except it's a hypothesis test, and so it's going to feel rather technical and even a little bit boring or something because you're dealing with numbers, things like that. Okay? So let's just say for a criminal trial, we have a defendant, and there's two claims, okay? Either two possibilities. Okay, the defendant is innocent. Innocent of the charges, or the defendant is guilty of the charges. Evidence is presented. And then and the conclusion of the jury is either the evidence has convinced us the jury that the defendant is not innocent. So we conclude he is guilty. Or the evidence is not enough, okay, or there is not enough evidence to bring about a conviction. And then we say the defendant is not guilty. Alright, so that's how we have it set up for criminal trials, okay? Alright, this is always my fear, okay? Because other classes are taught here, so I'm always afraid that something offensive is written on the chalkboard underneath, so. This almost looks like the normal distribution here, doesn't it? See? Statistics shows up everywhere. Alright, I have no idea what class this was. Okay. Just put up. Okay, so in hypothesis tests, we're going to be dealing with data. And here, our claims of guilty or not guilty don't go the same way that we have for criminal trials. It's not, is this number guilty or not? Okay. We say we set up two possibilities: the null hypothesis and an alternative hypothesis. Okay. We have the null hypothesis and we have the alternative hypothesis. Okay, in the null hypothesis, H0, and the alternative hypothesis is HA. So maybe, so one example is, you know, I could flip a coin, right? And we could ask, is the probability that the coin lands on heads, is that equal to 0.5 or not? Okay. So my null hypothesis, so for a coin flip, okay, so if we, let's say we're inspecting a coin. Okay. So let's say someone says, you know, at the, you know, the Super Bowl, they do a coin flip, right? And they say, you know, whichever team calls it gets to either choose to kick or receive or something like that. Right. Or and that goes for like, you know, overtime of NFL and things like that. Okay, so let's say somebody says, you know what, the you know, whenever there's a coin flip, the coin somehow, I don't know what they do, but they somehow, the coin favors one team over the other. Okay, let's say they say that. Okay, so now we're going to inspect this coin, and maybe there's some claim, maybe there's some truth to that. Okay, so here our null hypothesis is that the coin is fair. Okay, meaning if we had to put it symbolically, what would I write? I would write the proportion that it lands on heads is 0.5, right? So P is equal to 0.5, where P is the proportion where it lands heads. Okay. And the alternative would then be what? If one possibility is the coin is fair, what's the other possibility? It's not fair, right? The coin is not fair. And how could I write that symbolically? P is not equal to 0.5, okay? That the probability that it lands on heads is not 0.5, okay? Does that make sense to everybody? Okay, so let's say we have, whatever, the referee's NFL coin, okay? Let's say, this isn't how it works, but let's say somebody says, here's the coin that they use, and I think it lands on, you know, it doesn't land on heads half the time. It's something else, okay? Let's say somebody says that. Okay, so we say, okay, well, let's check it out, all right? And let's say somebody, so they flipped a coin 5 times, and out of the 5 coin flips, let's say it landed heads 4 times. Okay? So they say, there you go, look. You flipped it 5 times and it landed heads 4 times. Okay? That's way more than half the time. Does that prove that this coin is unfair? No, why not? Why doesn't that prove it? We flipped it 5 times and it landed heads 4 times, which is way more than half the time. Right? So 4 out of 5 is 80%. 80% heads. This coin landed heads 80% of the time. So why is that not convincing that it? So, well, we could never do a coin flip an infinite number of times. But well, if we flip it 5 times and it landed heads 4 times, that doesn't convince us. Why? Because we could have taken any old coin, a coin that we know is a fair coin, and we could have flipped it 5 times, and it could have landed heads 4 times. just by dumb luck, right? That's very possible. It could happen, and it happens quite often, right? If I gave all of you coins right now and told you to flip a coin 5 times, several of you would get heads 4 times, okay? Not all of you, but some of you would get heads 4 times. So because it happens quite often, just by dumb luck, with a regular fair coin, it is not convincing to us that when we get 4 heads out of 5 coin flips with the NFL coin, it doesn't convince us that it's an unfair coin. Does that make sense? On the other hand, let's say I flip it 500 times and it lands heads 400 times. Then would you be convinced that this coin is unfair? Yeah, I think so, okay? Because there, we're still getting 80% heads, okay? We flipped the coin 500 times and it landed heads 400 times, okay? If we tried to do that with a regular old ordinary coin, okay, it's possible, but it would almost never happen. The probability, we could figure out the probability of flipping a coin 500 times and getting 80% heads. We could figure out that probability, and we would see that probability is incredibly small. It's like 1 in a billion, okay? It'll almost never happen. So, because it would almost never happen just by random chance, and in our data it shows that it actually did happen, we would come to the conclusion that it's not a fair coin. Does that kind of logic make sense, right? It's kind of like in the trial, if somebody, a defendant says, no, I didn't commit the crime, the prosecution might say, well, if the defendant didn't commit the crime, how do you explain that the defendant's handprints were all over, the scene of the crime? The defendant's fingerprints were all over weapon, and we found traces of the victim's blood on the defendant's clothes. How do you explain that, right? Well, you'd either need some very good explanation to kind of dismiss the evidence presented, or we come to the conclusion, the defendant probably isn't innocent, and the simplest explanation is that the defendant is guilty, and that's why this evidence happened. Okay. So anyway, we're inspecting a coin. The coin is fair, or the coin is not fair. And let me just tell us one scenario and another scenario. Okay. So I'm just going to write what I spoke about and put it on the board, okay? So scenario A. Okay. We flip the coin 5 times. It lands on heads. Four times, okay? So our evidence is that the proportion that it landed heads is 0.8, which is much bigger than 0.5, okay? But so even though our evidence shows that the proportion is 0.8 out of 5 coin flips, this does not convince us that the coin is unfair. Why? Because we can take a fair coin flip it 5 times, and get 4 heads random chance alone. Okay? And that would happen quite often. Okay? And because it happens quite often, we can't rule out the possibility that it might have happened by random chance. Does that make sense with everyone? Yeah. Is that good? Okay. And on the other hand, we have scenario B. Okay. Flip the coin 500 times. It lands heads. This convinces us that the coin is unfair. Why? Okay, because if we took a fair coin and flipped it 500 times, we would almost never ever see it land on heads 400 times. Just by random chance. And because it would almost never happen by random chance, and yet our data has shown that it did happen, right? This is our data. It landed heads 400 times when we flipped it 500 times. According to random chance, it should never happen if it were a fair coin. But it did happen. So what do we conclude? We conclude that our coin is not fair. Okay? Is that logic of thinking okay? All right, because that's how we're going to go. Okay? By random chance. Okay? So so we conclude that our coin is not fair. Okay, so let me put there, and we'll try this. Is that all right? Okay, so let's try out scenario B. And let's see if you can tell me what is the probability of seeing 400 heads out of 500 coin flips if I have a fair coin. Can we answer scenario B? Do we know how to do this? So let's, huh?
No, we can.
We can, right?
Yeah.
Try that out, okay? So look at scenario B. Okay, so this is our data was 500 coin flips. We observed 400 tails, or 400 heads. If the coin were fair, what's the probability of this happening or something more extreme? Okay? Coin was a fair coin. And if you're not sure how we would answer this question, let me rephrase this. Okay? A fair coin, so this is rephrased maybe into something that you might recognize. Okay? When I rephrase it, I'll say a fair coin has probability P equal to 0.5, okay? A random sample of 500 coin flips is performed. Okay. What is the probability that I get 400 or more heads? Or in other words, P hat is greater than or equal to 0.8, right? 400 out of 500 coin flips is 0.8, so I'm asking, if P is 0.5 and I flip it 500 times, what's the probability that I get P hat greater than or equal to 0.8? We know how to answer this problem, right? Yeah. Or we should. Okay. So according to the central limit theorem, my mean would be what? The P hat that I should observe most often would be 0.5, right? Now what's my standard deviation? So my mean is 0.5, and my standard deviation would be the square root of 0.5 times 1 minus 0.5, which is also 0.5, divided by 500. So I get a square standard deviation of something. I'm sorry?
0.02236067.
It's too many. Just four decimals.
0.0224.
0.0224. That's good. Okay, so my standard deviation is 0.0224. And where did I end up? I ended up at 0.8. So what's my z-score here? Z is 0.8 minus 0.5 divided by 0.0224. So I get a z-score of 13.42. Okay? I'm 13.4 standard deviations away from the mean. Okay? This is an unfathomable amount. Okay? It's unfathomable. Right? Like I can't imagine. So let me just imagine what 13.4. Okay. Just to give you some perspective, this would be the probability of seeing a man who is about 9.5 feet tall, okay? Or it's the probability of, 13 standard deviations away from the mean. This is ridiculous, okay? We say 95% of the data is within 2 standard deviations of the mean. 99.7 is within 3 standard deviations of the mean, okay? If you look at your Z table, it doesn't even entertain the possibility of being 13 standard deviations away, okay? It shows that the table goes to 3.49 standard deviations away, and it even goes to Z 5 standard deviations away, okay? And at 5 standard deviations away, the probability is less than 1 in a million, okay? And so we're 13 standard deviations away. This is a ridiculous amount, okay? So we could either say, oh, maybe we were like so there's like a 1 in a trillion chance that a fair coin that's flipped 500 times ends up landing on heads 400 times, just by random chance, okay? So so this would almost never happen. So the probability of this happening, okay? So this corresponds to a probability that's practically 0. I mean, for all intents and purposes, the probability is 0, okay? But I guess we could imagine a universe where it might happen, but it would never happen, right? So, or practically it would never happen. So we can come to the conclusion that if this is actually what happened, okay? If our data shows that this has happened, we can eliminate the possibility that it happened just by random chance, okay? And so we can conclude that the coin is not fair, and that's how we get something that's so unusual, okay? Because if a coin is not fair, then 400 out of 500 coin flips might not be unusual. Yes, question?
So having that Z-score proves that it's not fair?
Yeah, because this is the probability of getting a Z-score so extreme is practically 0, okay? It's practically 0. All right, so let's try maybe like a more formal example, okay? So when we do hypothesis tests, we're basically saying, here's one claim and here's another claim. The null hypothesis is kind of the claim that what we observed could have happened by random chance, okay? And then we go through the probability steps and we'll figure out what's the probability that we observe this data. And if the probability of observing this data by random chance is high, that means our data might have been a result of random chance. We don't know. It might have been, okay? And then so we would say we don't have evidence to support our claim, or to reject the null. On the other hand, if the probability is incredibly small, or just small, we'd say this provides evidence to reject that claim. Okay, so let's say you want to know if an advertising campaign works or not. Okay. Do my TV commercials work? So we do an experiment, okay? And let's say we know that right now, if you know, when we survey the population, okay? Let's say right now, the proportion that like my product, the proportion that says they will buy the product, is 0.2. Okay, so 20% will buy the product. Okay, I want to know, okay, so I'm going to show my TV commercials to a bunch of people, and I'm going to ask them, do you want to buy this product or not? Okay. So we show the commercial to let's say 200 people. Okay. So if the commercial had no effect, if it had no effect on the people, we would expect, what proportion would we expect to like the product? 20%, right? We would expect the proportion of people who like the product to just still be the same at 20%. Okay. And if we showed it to 200 people, that would correspond to what? Like 40 people, right? Let's say after showing the commercial, let's say 46 people like the product. Okay, or say they will buy the product. Okay. So my sample shows p hat is equal to what? My sample says p hat is equal to 46 out of 200, which is equal to 0.23. Okay? So my sample proportion is 0.23, which is higher than 20%, right? So after I showed the commercial, 23% of people said they will buy the product. Okay? So does that convince me that my commercials work? Even if it's just a small percentage, does it convince you that the commercials work?
Yes.
Yes. Well, we're not sure, okay? We have to do a statistical test. Because somebody else could say, hey, I'm not convinced that the commercials work. Because if I just pick 200 people at random, okay? And if the true proportion is that overall 20% of the population likes your product, it could just be by random chance that I happen to get 23% of people that like the product, right? That could happen just by random chance. So we've got to figure out what's the probability that I got 23% of my sample liking the product just by random chance, okay? So then we're going to ask, what is the probability that this happened by random chance? Does that make sense? Okay, so see if you guys can do this, alright? You guys had to do something like this for the quiz already, so it should be no problem to do this? What's the probability that this happened by random chance? So this or something more extreme. So basically, what is the probability that p hat is 0.23 or more? You get that?
Yeah.
We need some help? Okay. Let's see what happens. Alright. So, what if we want to know what's the probability that I get 23% of my sample, okay, or a p hat of 0.23 or more, just by random chance, okay? Random chance meaning that the proportion that will buy the product is 0.20, okay? So, we're going to, in a hypothesis test, we have to set up a null hypothesis and an alternative hypothesis, okay? So my null hypothesis is that after showing the commercials, the proportion that like my product is still 20%, okay? So P is equal to 0.20. This is the proportion that likes the product after showing the commercials is still 0.2. Okay? In other words, the commercials had no effect. It didn't damage my reputation, but it didn't boost it either. Okay? That's basically what this null hypothesis is saying. Okay? And the alternative hypothesis is that my commercials make more people want to buy my product, okay? Is that the proportion that likes the product after showing the commercials is greater than 0.2. That's what I'm hoping for, right? It's greater than 0.2, okay? So, you know, I know some of you aren't planning on becoming statistics majors, but maybe you'll go into marketing, okay? This is the type of stuff that comes up and is useful, all right? Or political science or something. Maybe you want to know, is the campaign, are you gaining more supporters on the campaign, okay? These types of things come into play. All right, so we're asking, what's the probability? So my data, okay, the data is n is equal to 500, I'm sorry, 200, n is equal to 200, 46 like the product, so p hat is equal to 46 over 200, or 0.23. And the question is it possible that I get 23% just from random chance, even if the null hypothesis is true? So even if my commercials had no effect, is it possible for me to get a sample where 23% happen to like the product? So to answer that, we do the normal problem. 0.20, what's the probability that I end up out at 0.23? Well, my standard deviation is going to be 0.2 times 1 minus 0.2, which is 0.8, divided by 200. I get a standard deviation of 0.02828, right? Huh?
I put
283, yeah, that's fine, okay? I kept an extra decimal. If you round it off to 0.0283, your answer is still probably the same, right? Okay? So my z-score is what I observed, 23%, minus what I expected. If the null hypothesis were true, I would have expected 20% of my sample to like my product. I divide that by my standard deviation, and I get a z-score of 1.06. So I look up 1.06 in my table, and I get, what do I get, 0.8554, right? Which means the area over here is 0.1446. I do 1 minus 0.8554. Alright. So, my answer is 0.1446. So basically 14.5%. 14.5%. It says, anytime I go and take a random sample of 200 people, even if my commercials had no effect, anytime I go and take a random sample of 200 people, about 14.5% of the time, I'm going to get a sample where 23% like my product. Okay? That's going to happen just by random chance. So, can we rule out the possibility, or are we willing to rule out the possibility that it happened by random chance? No, okay? 14.5%, that's kind of a big percentage, right? That's the probability of just throwing a cube and getting the number 6, okay? Or throwing a die and getting the number 6. It happens quite a bit, okay? So I can't rule out the possibility that, you know, it's exciting. I got 23%. That seems like, oh, great. a lot of people like my product, okay? Or I mean, that's more than 20%, so maybe I'm excited. But then somebody could say, sorry to burst your bubble, but just by random chance, I could get 23% anyway, okay? And so because of that, it's not enough evidence to convince me that the commercials work. Okay? Yes?
Is this because it's only like one standard deviation? Like if it
Yeah,
was more
because our data is only one standard deviation away, alright? Or basically, our data shows that the probability of getting our data or something more extreme is about 15%. It's about 14%. That's not a minuscule amount, okay? It's not a small amount, okay? So we can't rule out the possibility that our data just resulted from random chance, okay? So 0.1446 is not small. So we cannot rule out the possibility that the commercials failed but I happen to get a quote lucky sample or 23% like just by random chance. Like that. So at the end of the day, my conclusion is we do not have evidence that the commercials work. So does that mean my commercials have definitely failed? No, it doesn't mean that my commercials have definitely, it's not evidence that it failed, okay? At this point, all I can say is we surveyed 200 people, and it's not enough evidence to prove to me that the commercials work, okay? So either I need to survey more people, show more people the commercials, or something else, okay? Is that all right? Okay, let's. Why don't we take a short break, and then we'll come back and we'll do more of this hypothesis test next time.